Okay, so looking at what we have for Math 285, lab exercises 8, and I'm just going to show you some of the Maple simulations that we have among these items, and the first of which we are looking at Maclaurin series expansion. And so we have, for the first function, we have the cosine of 3x, and we'll be getting into this. And if we look at setting up what we have in Maple, so if I look at establishing a new worksheet, okay, and in terms of how you're going to get to series, now the first function was the cosine of 3x, and you do not have to enter any special kind of with commands, okay, and for Maclaurin series, okay, in Maple you can just type in series and then the function of interest. So we have the cosine of 3 times x, and we can say that for the first few terms, okay, say we have x going from 0 to 7. Then upon pressing enter, and so you have on display what will be the first 4 non-negligible terms of what we have in this series, okay, for the function cosine of x. And for the second item, okay, we have our function, which is going to be x squared times what is going to be the sine of 4x. And if we look at, we'll say x will go from 0 to 7. Okay, so just a couple of non-negligible terms. And let's say if I go from 0 to 15. Okay, so you got your first 4 non-negligible terms in Maple. We have 4x cubed minus 32 thirds x to the 5th, and so on. And if I take what I have with the next function, okay, and this time we have x times e to the 3x. So you have x times, okay, and for e, you can either get e from the palette. You cannot type in the e from your keyboard, okay, and so you can say we have exp, which will be in reference to the natural logarithmic base, and we have to the 3x power, and we have x go from 0 to 7, and we do have some of the first non-negligible terms. Okay, now if I take the antiderivative, let's see, I think I'll just type it in. Okay, the series, and from the palette, okay, you have the integral of x times e. In this case, for Maple, we have e xp 3 times x. Close out, we have dx, and we have x to go from 0 to 7, and you might have an added character in comparison to what was done by hand. And in this case, we do have -1/9, okay, but if you took the antiderivative of what we have for x times e to the 3x, okay, we have x at 1/2 x squared, antiderivative of 3x squared is x cubed, and so on. And that -1/9 is like part of the constant that would be in the package for the integration. And now, for what we have in the case of the power series expansion, okay, we had with our next problem, and that was the quantity of 1 plus 3x, and we have raised to the 5th power, and we have x to go from 0. Let me just give you a case here. If I have going from 0 to 4, okay, you're going to have an incomplete expansion, okay, because we have only going out to x cubed. And say if I go out to 7, okay, you're going to have the full expansion. And if I were to go out to, let's say, 27, we're just going to have a surplus in terms of how far to go out in x, because this is going to be a finite series expansion. And likewise, okay, for what we have in the next item, okay, and we have the binomial. In this case, we have 3, and that is minus 2x quantity to the 5th, and I'll just keep the x from 0 to 27. And your full series expansion, we have with these 6 terms, 243 minus 810x, and we have all those terms in ascending order, but you can also display in descending order as well. Okay, now when we looked at the values of the square root of 500 and the cubic root of 500, and let's say that for what we have regarding the square root of 500, so you have in the series we have 1 plus x, and with square roots you're looking at raising the expression to the 1/2 degree, and we're looking at going out to x to the 4th. I think x going from 0 to 5 is going to give us the necessary terms, and yes, it does. Okay, now when we looked, okay, so in the expansion, this is what we have in x, so we're going out to x to the 4th. Now if I'm looking at evaluating, okay, now for the square root of 500, okay, now the nearest perfect square is 484, okay, and the number 500 is going to be 16 more than the square root of 22, so you have a difference of 16. And looking at, say, evaluating what we have here, okay, so you have a surplus of 16 over 484, and you can reduce that to 4 over 121. Okay, let's say that for 16 over 484, if I'm evaluating, so this is the exact result. And let's say that if I take this number and I multiply 22, so carrying out to what we have up to x to the 4th, where x happens to be at 16 over 484 or 4 over 121. Okay, this is our result in the case of what we have in approximating the square root of 500, and for what we have in terms of a decimal value. So to like the nearest 10 decimal places, we have 22.36067975. And if I did the same thing, and let's say that, see how that compares if I were to expand to 20 decimal places. Well, in this case, we have 22.360679751. Okay, now for the cubic root of 500. So if I look at just the series expansion, okay, in the cubic roots, or the cubic root of 1 plus x, and see how it looks for, yeah, x going from 0 to 5. So I had the expansion all the way out to x to the 4th. Now, for what I have in terms of the nearest cube, that is going to be the cube of 8, and the cube of 8 is going to be 512. And what is going to happen in this case is that if I go with the nearest cube, what I'm going to be looking at is I'm going to be evaluating at a point, and in this one, so you have for x, so I'm going to be like 12 short of 512. You can write as negative 12 over 512, or you could reduce the ratio, but I'm just going to do it this way. All right, so we have this number here. Now the cubic root of 512 is going to be 8, and if I take this number and multiply 8, I'm going to come up with this ratio, and if I approximate, say, to the nearest 10 decimal places, so I have a 7.937005262, and just taking what we have and expanding to 20 decimal places, I have 7.937000526, okay, 15, okay. And so these are samples of what we have in solving the 8th lab exercises through the use of Maple.